Welcome to Learning Gateway. Previously, we have solved some question of distribution where the data appears vertically or horizontally. But in both cases, the data was in one line only. Right now, today, we are going to solve a case where the data appears in 4 different rows. And we have to arrange all of these 4 rows accordingly. The problem we have today is that there are 6 passengers who are going to travel in a small plane of 8 seated, and the passengers are N, P, Q, R, S, T, and there are only 8 seats in that plane, and we have to set them according to these restrictions. Right now, according to these restrictions, N wants to set alone, mean he wants a VIP protocol. The second one restriction is that the P and R must be adjacent. They look like they're close friends and want to discuss something. Okay, after that, the third restriction is that row 1 and row 3 will be the rows in which only one passenger will sit. And the last restriction is that the Q must not sit adjacent to S. I think they are from different political parties. That's why they don't want to sit together. And there is only one passenger, T, which is neutral. So first of all, we have to symbolize these restrictions or convert these restrictions to symbolic form. Here you can see that I have already converted all of these restrictions to symbolic form. But at the top, I have wrote down all the name of these 6 passengers. The purpose of this is that in a time of when we are going to analyze the restriction, and we have to recall all of these individuals. And if someone is missing in that restriction, we can find him in above line. Right now, the first restriction we have that N must be alone, that N implies alone. As I have mentioned earlier, that there is no hard and fast rule about the symbolic or about the converting these verbal paragraph to symbolic language. So I just simply wrote down that N implies alone. The second condition is that P and R will be adjacent. So I just wrote down that P dot R, that both of them will be sit together in a row. The third condition we have about this arrangement that row 1 and row 3 will be having only one passenger. And the last restriction is that the Q must not be sit together with S. Okay, before moving to the question section, I just want to share with you a valuable technique that you have to look out for the implied information or implied link information before solving your questions. So if we look above to our restriction that there are only 6 passengers and row 1 and row 3 will contain only one passenger, it's mean that row 2 and row 4 will have 2 passengers. And in 4 condition that Q must not sit along with S, and as we already know that P and R, they will be 2 persons to sit in row 2 or row 4, and the second 2 person that will be P and 1 person from these 2. That could be Q, T, or S, T. Right now, we have pulled out the link information from this given data, and now we are going to answer the stated questions. The first question we have that which of the following passenger could be assigned to the seat in the same row as Q. Right now, you can see that I have told you that whether Q will be seated with a T or S will seat with a T. So the T is the one that will be sitting in a row where the Q is sitting. Therefore, the correct answer is option E. Let's move to the second question, that if R and P are in row 2, which of the following must be true? Here I just wrote down that R and P are in row 2, it implies, as we know, that in row 1 and row 3 there will be only one passenger. That could be N or the one from Q or S. In the same way, that could be Q or S. But T in each case have to move over here, and the second person, the T with T, could be Q or S. But in both cases, T have to move to the last row or the row 4th. So the condition we have right now that N is in row 1. Here you can see that N is row 1, but that there is a probability that N appears in row 2 as well. In option B, that Q is in row 1, so Q could be appear anywhere in row 1 and row 3. The third option is that Q is in row 4, so that is not possible. Option D is S in row 3, so it could be in row 3 but as well and as in row 1. And the last one is T is in row 4. So this is the only condition about which we are 100% sure that in each case T must have to move to the 4th row or must appear in the last or in the 4th row. Therefore, the correct answer is option E. Let's move to the next question about this arrangement. What is the total number of passengers that are eligible to sit in the same row as T? Okay, you can see over there to the last option or the last restriction we have about this arrangement that Q must not be sit together with S. So therefore, with T, either Q will sit or S will sit together with T. So there are only two possible passengers that could be sit together with T on the same row. So the answer we have is B. Okay, let's move to the last question about this arrangement, that if Q and T are assigned to sit together in a row, then which passenger could be assigned to sit in row 3? Right now, we know that the two passengers that could appear in row 2nd and row 4. After this arrangement, we have only two passengers left, that is N and S, that could appear in row 1st, N and S, and row 3rd. But if we look down to the option we have, that is option A is P, option B is Q, option C is R, option D is S, and option E is T. It means N is missing. So the left one or the one option we have, that is S, that S will appear in row 3. So this was all about the distribution third case, and as I have told you in start that if you derive the implied information at the start or before going to solve your case or answer to the question, that will be so easy for you to analyze your questions. I think that was not that much difficult and will be beneficial for you as well. Moreover, in our next lecture, we will solve a case of distribution where the data will appear in 2 dimensions. Means at a time we have to find out the arrangement of these individuals, and secondly the cars they have, each and every individual. But before closing this lecture, let me give you an assignment relevant to our today's lecture, that a farmer want to plant 5 different kind of vegetable which are named over there, in which he plant 3 vegetable each year. Right now you have to find out that which of the 3 vegetable is going to be planted this year or the next year. This data will appear same like this example we have solved today in a row, and you have to answer only 2 of the questions about this arrangement. That was all for today. See you in next lecture.